Okay, curve fitting with linear models. In other words, what we're going to do, given a set of data, we're going to find the equation of the line that best fits that data. Researchers such as anthropologists are often interested in how two measurements are related. The statistical study of the relationship between variables is called regression. So we can find regression, we can do it by estimation, by using a couple points that we have, or we can use Ruth's favorite tool and find a really good fitting line with our technology. Okay. Now, when we look at a set of data with a scatter plot, those sets of data all have what we call a correlation. The correlation may be positive, which means that the slope of the graph will go up towards the right. It'll all kind of form a pattern that goes up to the right like this one here does. Or it could have a negative correlation if the data goes down to the right. So if you have a positive slope with your data, you have a positive correlation. If you have a negative slope, you have a negative correlation. But the slope and the correlation are not the same numbers. Okay? And then if you have numbers that are just, the points are just all over the place, then there's basically no correlation at all. So when we're trying to find a line that fits the data the best, then we're trying to find a line of best fit. And so when we do it by hand to find the line of best fit, we usually want to have the same number of points above and below our line. So we're going to take a set of data here, and this is from a meteorology application, and we are going to find our line of best fit for this data. So here we have Albany and Sydney are about the same distance from the equator. Okay. That'll be Albany, New York, and Sydney, Australia. It says make a scatter plot with Albany's temperature as the independent variable. So where's that going to go? On the x, yep. And name the type of correlation, whether it's positive or negative or no correlation, and then sketch a line of best fit and find its equation. So we got a little bit we're going to do here. Okay. So first of all, we're going to put this data on a scatter plot. Now, do I have to start at 0 when I make a scatter plot? No, not necessarily. I really just need to have my data points there, right? Okay. So here, if we look at Albany, which is going to be our independent variable, so x, the smallest number here is 31. And if we look at, and the largest number is 70. Sydney, the smallest number is 46. And the largest number is 66. So we want to make a scatter plot with those data in it. Okay. So when I start numbering on my scatter plot, I can, if I choose to, I could start numbering at 30 for Albany, and I could start numbering at 40 for Sydney. Okay. Because the line we're actually going to find, the best fit line, we can do it that way. We don't have to necessarily see our y-intercept. If you want to, you can. So if we want to, we could start, just go from 0 to 100 on the x or the y, or go from 0 to, I guess we could go to 70 or 75 if we wanted to also. So I'm going to change my scale on here a little bit. So my properties. So I'm going to go up to, let's see, we'll go to 80 for our x. And we're going to go by tens. And if I want to, I can change it. Should I change that and start somewhere besides 0? How many of you would rather see 0 on your graph? Okay, so we'll start at 0 then still. Okay. And for our dependent variable, that we'll start at 0 there. And we only need to go to 70 on that one. And we'll go by 10s there also. So in our plot our points, so we've got the point 31, 65 is our first one. So 31, 65 about here. And 41, 63. Okay, so there's our points. Okay, so this data is going down to the right, so that means it will have a negative correlation. Okay. All right, so then we want to draw our line of best fit. So we want to draw a line that goes through the data to where we have about the same number of points on each side of our line. So if I draw the line here, we're going to end up with probably about 4 or 5 points on each side of our line. Except this doesn't like me. So my line will go through about here. About like that. That's a pretty straight line for me. All right, so there's our line of best fit. Is it going to be perfect? No. Okay, but it should be pretty close. All right. So now once I've drawn that line then we want to find 2 points that are on it that we can use to find the equation of the line that goes through those points. How many of you remember how to find the equation of a line? Hopefully all of you do, because we didn't do it that long ago. Okay. All right, so let's find 2 points, and I actually have them right here that we're going to use to do this. Excuse me. Okay, get that out of our way. Okay. Oh, those 2 points won't work. All right, so if we look at 2 points that are on the line, let's see. What do you think? Ones that are pretty close. Who did it on their paper? Anybody? Megan, did you draw a line through there? Okay, what 2 points intersect your line, do you know? You have no idea? You can't tell which points are on yours? Because mine, since I drew it freehand, I don't really, but it looks like that we could focus on maybe this one right here, right? That looks like it's on the line. Okay. And what point is that one? Let's see, it's a little before 60 and about 53 looks like, maybe 59, 53, okay. Yep. So we've got May is one of our points. Okay. And it looks like this one right here is pretty close to on our line also, and that one is 70-48, so that one would be August. Okay, so let's use those 2 points then to find the equation of our line. So we got 59-53. And 70-48. So we're trying to find the best fit line, so we want y equals mx plus b. So what am I going to find first? The slope. And how do we find the slope again? Okay, so we want to subtract the y's and that divide that by subtracting the x's. Okay, you're kind of close. So we'll do 48 minus 53 divided by 70 minus 59. And hopefully we get good numbers to work with. So this is -5 over 11. It's going to be our slope. Okay, that's not a great number, but we can work with it. Okay, so then what do I do then to find the equation of the line that goes through them? What form do we use to find the equation of the line? That was thunder. Oh, what are we going to do with you? Okay, so we're going to use the point slope form to find the equation. Okay. So we do y minus y1. Does it matter which point I use for point slope form? Nope. All right, so let's use the 70-48. So y minus 48 equals our slope, 5/11 times x minus 70. So and this would be a problem to where if you wanted to work with decimals, you could work with decimals also. Might make it easier as far as doing some of the calculations too. Okay. So we get y minus 48 equals -5/11 x minus, plus because we have a negative times a negative, 350 over 11. Okay. So I'll take my work over here then. So we need to do what now? Okay, add 48 to both sides. So we get y equals negative 5/11 x plus, and our calculator will do that for us if we need to. We could do it by hand also if we needed to. All right, so we could take our calculator and do 350 over 11 plus 48. And as a decimal, we get that number there. And if you want a fraction, we can go math and change it to a fraction. And we get 878 over 11. Okay. Or probably decimals would be a little bit nicer to work with in this case. So we can say y equals, what's 5/11 as a decimal? 0.45? 0.454545. Okay. So negative 0.45x plus, what was it, 79.18, wasn't it? Okay. So we make a scatter plot, take those numbers and figure out whether we have positive or negative correlation. Pick a couple numbers that are on our line and graph them. Then find the equation of the best line that best fits. Okay. So I want you to do it with this. Check it out here. You can see here for the correlation that because these are all grouped really closely together along a line, that they would be close to -1 if it's a negative correlation. And down here, this one on the right, that one, since they're going really close to a line, it would be closer to +1. And when we get a correlation coefficient, it's called, for R, we want that number to be as close to 1 or -1 as we can get, because then it tells us we have a really good fit, that our line fits the data really well. And if we have some that aren't as good, then we end up with these situations here, okay, like -6 or +6 or 0. So we're going to learn how to use our calculator to, 1, make a scatter plot, and 2, find the equation of a line, the best fit line for a set of data. So with your calculator, first of all, we're going to look at putting it in our list. So we want to put our data in a list. So to access your lists, first of all, okay, we go to Stat and then over to Edit. So Stat, push the Stat button for statistics, and then Edit, which is the very first one, and then we hit Enter. And then you should see lists on your calculator. Okay. Now, how many of you have stuff in your lists already? Okay, the first thing we want to do is get rid of that stuff for the information that we're going to use. So to clear your list, go up to the list number by pressing the arrow key to go up. All right, so it's highlighted. And then you press clear and enter, and that'll delete everything in the list. Up to the list number, press clear and enter, and so that it's completely empty. Okay. All right. And now we're going to put length in list 1 and height in list 2. So you just type in the number and hit enter, and it'll go to the next one. And make sure when you're done, you double check your numbers to make sure you type them in correctly. So as much as in some situations, estimating works pretty good, but a lot of with statisticians, they want exact ones, the closest they can get, so they use their technology to be able to find the best lines. Okay? Now, we want to make a scatter plot with our calculator. I know we're going to get just maybe one more thing done, and then we'll pick up and review it tomorrow and do it tomorrow. So to make a scatter plot, all right, tells you right here, turn the scatter plot on. Press second and y equals. So obviously you're going to have to do this in class, right? Spend time in class working on this. Second y equals, and you hit enter, and then we turn it on. And then you can see that it's highlighted here. The first one here should be highlighted, and that's the scatter plot. And now, okay, so we have it on. And if you go to your y equals right now, you would see that plot 1 is highlighted. Okay, that tells me that I have a plot on. And if you want to turn it off, you can just go up there. So if I want to turn it off, I can just go up there, hit enter, and now I've turned it off, back off again. So you can actually turn them on and off from your y equals screen. Okay? All right, now, we want to make a graph of our scatter plot. So we're going to press zoom and then number 9 for a viewing window that'll be a fit for that data. So press zoom 9, and you can see that that data, it actually makes a window for you that fits that data. Okay. So we put our data in our list by stat edit. We turned our plot on, and then zoom 9 fits a window to our data. Okay. Then we're going to find the line of best fit and the correlation coefficient. Okay. So to do that, we're going to press stat again. Okay, this is going to find the best fit line, and then go over to calc. And you can see here at number 4, it says linreg. Okay, that's linear regression, and ax plus b. Hey, that's our y equals right there. Y equals ax plus b. Okay, so we're going to choose number 4, and everything should be set for you here. It should say your x list is list 1, your y list is list 2. Okay, but we're going to do one more thing. We're going to go down here to where it says store regression equation, and we can tell it to put it in our y equals. So press alpha and then F5. Oops, sorry. Alpha, what do I do now? Alpha and F4, sorry. And then you can put it in Y1 there. Okay. All right, so I got to go back. Stat, over to calc, number 4. Okay, go down here to store regression equation. And if I press alpha and trace, basically, I'm telling it then that the equation I get, I want it to go in Y1. Okay. And then we hit calculate, and there it is. Okay. This gives us, says R is 0.9859. That says it's a really good fit. Okay. And now if you press graph, the line is there. Okay. All right. We're going to talk about this more tomorrow, and we'll go back through the whole thing again. All right. And we'll write down these steps for doing this also. Okay. Your assignment tonight then is to do numbers 3 through 6 on page 146 and 147. Okay. So what I want you to do is you're going to make a scatter plot on your graph paper, draw a line of best fit through there, and then find an equation. Okay? Now, the book tells you to do some other things, but I just want you to do those 3 things. Scatter plot, line of best fit, and find the equation of your line. Okay? And then we'll learn, tomorrow we'll go back through that with a calculator, And because finding regression is something that can help you with a lot of different things.